Good morning to one and all. I am Bogala Vinod Reddy and I am from ECD section and my roll number is 20951 capital 04P4 and today my topic is Fourier cosine integral theorem where the subject is MTD. MTD means mathematical transformation of techniques. And introduction, brief introduction about the Fourier series. Fourier series is used in the analysis of a periodic function. Example, heat wave or a formula, sound wave or formula, full wave rectifiers, and the Fourier series makes use of orthogonality relation of sine and the cosine function. It decomposes the function into the sum of sine and cosine functions. The computation and the study of Fourier series is known as the harmonic analysis. This is the introduction about the Fourier series. And next, Fourier series and its representation. Representation of a function over a certain interval by linear combination of a mutual orthogonal function is called the Fourier series representation, where f of x equals to a naught plus sigma n equals to 1 up to m, where the an of cos n pi x by L plus bn of sin n pi x by L, where the a naught equals to, where the divided by the a naught an and bn, where the a naught is the 1 by 2L integral of minus x to plus x f of x dx, where nn is an equals to a by n integral of minus x of x f of x. Fourier series and its representation. Representation of a function over a certain interval by linear combination of mutual orthogonal function is called the Fourier series representation, where the f of x equals to a naught plus sigma n equals to 1 to n, where the n of cos n pi of x by L plus bn sin of n pi x by L of bracket close, where the an and the a naught and bn are written as individual, where the a naught equals to 1 by 2L the integral of minus x to plus x f of x into dx, where the n equals to 1 by L integral of minus x to plus x f of x of cos x n pi x by L into dx, where the bn equals to 1 by L of integral minus x to plus x f of x sin of n pi x by L into dx. This series is known as the trigonometry Fourier series. This is a Fourier series representation and the advantages of uses of Fourier series. Discontinue function. One of the advantages of Fourier representation over the some other representation, such as the Taylor series, it is the may represent a discontinuous function. An example, idea of a sawtooth wave in the preceding section. Periodic function. Related to these advantage is the useless of a Fourier series representing a periodic function. If f of x has a periodic of n 2 pi, perhaps it is the only natural that we have expanded a series of a function with periods 2 pi and the 2 pi by 2 and the 2 pi by 3 so on. It continues. This guarantees that if the representation holds for all finite of x. And next, example for the rectangular plus triangle in the Fourier series, where the seen the diagram of 4.6 periodic signal with the fundamental periodic. Take on x-axis 0, 0.5 and 1 and 1.5 so on, and the similar to the this side 0. minus 5 and the 1 minus 1 minus 1.5 and so on. Take the y-axis of t and from figure t equals to 2, so omega t equals to 2 pi by 2 equals to pi. Clearly x of t satisfy the Dirichlet condition and thus has a Fourier series representation. This is the example for the regular plus triangle and the even or odd periodic function. This even and odd periodic function can satisfy or represent the Fourier transformation of a cosine or the sine. when the even function f of minus x equals to f of x, odd function is f of minus x equals to minus f of x, some characteristics even plus even equals to even, odd into even equals to even, odd plus odd equals to odd, odd into odd equals to even, where the even into odd equals to odd. If f is even, then integral minus a2 plus a f of x dx equals to 2 into integral 0 to a f of x dx. If the f is odd, then integral minus a to a f of x dx equals to 0, where the function f means function is in even, then it is to be a sine series, and the f is an odd function is an odd series, it's considered as a sine series. An example even function. For the even function, cosine function is available, where the cosine function f is cos of theta, where the graph of cos theta is placed between the y with respect to y-axis cos theta, and with respect to x-axis is 0 pi by 2 and the 3 pi by 2, similar to the opposite side minus pi by 2 minus 3 pi by 2, and the graphs should be similar and symmetric to the x-axis. This is an example or the cosine graph. And the Fourier series of a periodic function, if f of x is periodic 2i, then we define the Fourier series of f says fs of f as fsf of fs equals to a naught plus summation of n equals to 1 to infinity an cos n pi by x by l plus bn of sin n pi by x into l, where the coefficient was given by the Euler's function a naught equals to 1 by 2 pi integral of minus L to plus L f of x into dx, an equals to 1 by L integral of minus L to plus L f of x cos n pi x by L into dx, bn equals to 1 by L of integral minus L to plus L f of x sin n pi of x L into dx. This is the Fourier series of a periodic function. And half range of cosine, if f is a symmetric about x equals 0, also about x equals to L, because of its symmetric about the x equals 0, f is an even function. When is the f function is an even, then we can consider as a cosine Fourier series, and its Fourier series will contains only cosines, no sine. Further, periodic is 2L, so L is half of the periodic element, where the fs function of f of x equals to a naught plus summation of n equals to 1 infinity n cos n pi x by L, where the limits are 0 less than x less than L, where the a naught similar to the a naught equals to 1 by L integral of 0 to L f of x dx, where the n equals to 2 by L integral of 0 to L f of x cos n pi x by L into dx, where the b naught equals 0, because of the b naught equals to sine. B naught is a quotient with a sign, where the sine equals 0, b naught equals 0. Proof: for the half range of cosine case, the periodic is 2L, a naught equals to 1 by 2L integral of minus L to plus L, f expected of x into dx equals to 1 by L integral of 0 to L f of x dx, where the an equals to 1 by L integral of minus L to plus L f of x cos n pi x by Lx by L into dx, where equals to 2 by L integral of 0 to L f of x cos n pi x by L into dx, where the bn equals to 0, because of the coefficient of it is the coefficient of sine function. For example, find the Fourier cosine transformation of e power ax in minus e power minus 2x solution. We know that Fourier cosine transformation f of x equals to fc mod of f of x equals to under root of 2 pi integral of 0 to infinity f of x cos x dx, where f of x equals to e power minus a pi minus e power minus 2x by s, where f of c equals to e power minus 2 ax minus e power minus bx by x equals to under root of 2 by pi into integral of 0 to infinity e power minus a by minus e power minus bx by x into cos x dx. By simplifying this, we can lastly verify that 1 by under root of 2 by log of x square plus b square by s square plus b square. This is a simplified equation. This is the example for us. Also, and the end. Okay. Thank you for giving this opportunity. Thank you for listening to all. Thank you to IRE.